Welcome everyone to geometry. This is the first lesson, lesson 1-1. And geometry is a pretty cool subject in my opinion. It's much different than algebra where you're always just trying to solve for x, solve for x, solve for x. Geometry is very, very realistic, or at least it can be. So let's just get started here. There's two terms here at the top. As you can see, we've got a postulate, which is an assumption in geometry. And all that means is they're just words that somebody made up and everyone agrees on. So I like to always bring it back to like realistic situations. So like first off, like why is the sky blue? You know, and it's like, what? What do you mean by that? And it's like, well, I guess really why is the color blue called blue? And it's kind of just because they called it that and everyone agreed. They're like, yep, this is going to be blue right here. So an assumption in geometry is called a postulate, and that's stuff that people just basically made up and everybody's going with. And then a theorem is a whole different ball game. It's similar but very, very different. It's a statement that can be followed from postulates, definitions, or previously proven theorems. And the main thing here is that theorems can be proven, you know, and we will talk so much more about theorems another day. You probably remember like the Pythagorean theorem where a squared plus b squared equals c squared. But today we're talking about really the three undefined terms in geometry. And it's like, what does that mean? Like, it's weird that we're going to have to define them as well in their undefined, but they're just like the three things that they made up to start this game called geometry. So the way I like to roll with it is geometry is just like a game. So if we were going to like create a brand new game, let's just say we're going to create the game of football, you know, like what's the very first thing we need to do? Well, it's probably come up with some rules, you know, and how do you do that? Well, you just kind of make them up. So imagine we're creating the game of football. Now, we know it for the NFL, of course, you know, and we just go like this. All right, here's what we'll do. We'll have this game, right, and we're going to have 11 guys on this side. We're going to call them the offense. Why 11? I don't know. I just made that up, you know. So, like, if there's 11 guys on this side, there should probably be 11 guys on the other side, right? They're like defense, right? So, again, 11 on 11. Why? We made it up. And then here's what we'll do. We'll give the offense this ball. It's not even round. Right? It's a weird shape, right? But why? I don't know. I like it. It's just I'm going to use it. Right? So we got this weird ball, and here's what they got to do. You get 4 tries to advance the ball 10 yards. Why 4 tries? Why 10 yards? I don't know. I just made it up, right? But if you can get the ball 10 yards further than where you start on this like line of scrimmage, then you get another 4 tries to like get the ball further down the field, because here's what we're really trying to do, guys. Like, I got it. There's this zone down there at the end, right, where like if we get the ball in there, we get some points. Well, what's that zone down there called at the end? I don't know. I ain't got a name for it. Look, so like how about we call it the end zone? Yes. End zone. Perfect. What a great thing. So if the offense gets the ball in the end zone, we're going to give them 6 points. What? Why 6 points? I don't know. I'm going to make it up. But wait a minute. If we can get that ball in there for 6 points, we're going to give you a chance to give some extra points, right? And here's what we'll do. We'll let you either like run the ball in or pass the ball in from like the 2-yard line, right? And we'll give you 2 extra points. You can get that in just one shot. Or what we can do is we'll let you like kick the ball through this big thing called like these upright type things that we'll just call them uprights, right? If you could kick it through there, we'll just give you 1 point, you know? So it's probably easier because to kick it through there because there's people who are really good at kicking. But the whole idea is like all this stuff was just made up, and the same thing happens in geometry, man. They had to create this game called geometry, so the first thing they made up was called a point. And a point represents a location, and it has no size. Now, if you're watching out there in video land, this might go a little fast for you, so you can always pause the video. But first of all, what does this mean? Represents a location, has no size to it whatsoever. Well, remember, we're talking mathematically here, right? So, like, The points that you're pretty familiar with from your algebra is like if we had a coordinate system and I plotted this point 0, 0, like it really has no size. It just represents that location on a map, right, or on a coordinate grid. So what we mean by no size is out of the dimensions in our world, which we have 3 that we usually like to go by, length, width, and height, a point has 0 of those. It has no length, no width, and no height. And that is hard to understand, like, realistically, because if I ask you to draw a point, which we will today, like, you have to actually draw this physical dot right here, which does have some size. But mathematically, that point has no length to it, no width to it, and no height. And you can see I called that point A, and I used a capital letter. That's how you have to name points, is by a capital letter. Capital letters mean something in math, lowercase letters mean something else. So capital letters, geometry is picky with all of these like notations right here. So for example, this guy right here is called point A. Well, I'll tell you what, mathematicians hate to write also. So like when I want to write point A, I do not put the word point in front of it. I just use the capital letter, and everybody knows that that is called point A because it's a capital letter. Lowercase letters mean something else. So the first undefined term in geometry, the one they just had to make up to start making this game, was we better know what a point is. So, all right, they all agreed this is going to represent a location, has no size. Why did they call it a point? They made it up. So the second one, which we're very familiar with, we graphed a bunch of these back in our algebra days, is a line. A line is the set of all points extending infinitely in 2 directions. And you can always pause the video to write this down. By the way, there will be vocab tests in this class. It's kind of weird because if you don't know what the words mean, this subject will be very, very difficult. So lots and lots and lots of vocabulary. So the set of all points extending infinitely in 2 directions is a line. What we take it back to algebra, because we're familiar with that, is our good old-fashioned like number line. So like if I had 0 right here and 1 right there, and I just like pick a point in between there, and I asked you, hey, where's that point? Most people would say, oh, that's at like 0.5, like that's halfway between. Awesome. And then I could go like halfway between those, and that'd be like 0.25. And then halfway between those, and that's 0.125, and I could do that again and again and again. I could go anywhere and put another red dot. I could do that infinitely because between any 2 points there is always another point. There's so many points in a row that they end up just like looking like this line. That's why it's got infinite number of points. And when they say 2 directions, that's the arrowheads that we're always going to make you draw when we graph these guys. So how many dimensions out of length, width, and height? It's just got 1. Lines only have 1 dimension. We usually call it length. It doesn't actually matter which one of those it is, but the length. And I know, again, you could draw like a fat line or a skinny line. You know, it doesn't really matter. There is no width to it or height to it. It's just got length when we're talking about a mathematical concept right here. And then, of course, we get into our notation. So how do we name a line? There are 2 different ways to name the line. First way, bada boom, by any 2 points on that line. You can see a bunch of points right here. And notice this guy out here, he's not on the line. He's somewhere off the line. We'll talk about him a little bit later. But I got a bunch of points on the line. I'm going to pick any 2. So boom, A and B are on that line. I could call that guy line AB. But again, mathematicians hate to write, so we have symbols for it. Since A and B are points, they got to be capital letters. But this right here doesn't actually say line AB. I need to put this line bar above it, which looks like this, where it's got the 2 arrows on it. We'll learn in the next few days that this guy right here that doesn't have the arrows will be for a segment, and if we have just 1 on there, that would be a ray. So we need both arrowheads. It's like line AB. So that's 2 points on the line. I could do that again, though, right? I didn't have to use A and B because there's a bunch of points on that line, so I could call it line like BD, and I have the line bar above. As long as I got the line bar and I use capital letters and I use two of them, right? I could call it line, BA. It doesn't matter. You don't have to go like from left to right or anything like that. But that's by naming the line by two letters, right? By any 2 points on that line. There's another way, because mathematicians, once again, get tired of writing. That's still a lot to write. But do you see this little letter right here? He's not even capitalized, right? He's a lowercase letter. He's supposed to be cursive, but in the world that we live in, even though there is cursive fonts on there, a lot of people just use italics. But with a lowercase cursive letter, if it's in the picture, that right there is like line M, which I know it can be hard for you guys to write in cursive. I'm not expecting perfect cursive, but if you could just make him lowercase, that is the main thing. But I don't put the word line in front of him, and nope, we don't put the line bar above it. Like this says line M, and we don't want that. So if you just use a lowercase cursive letter, doesn't have to be cursive, but it's supposed to be cursive, that's another way to say that's a line. Of course, it has to be there in the picture. Like if it's not there, you can't call it that. So that's a one-dimensional object, the line. So if you had points on the same line, did you see like A, B, C, D, they're all on the same line? That's got a fancy word. That's called collinear. Collinear. It's got to be spelled correctly also. I'm a big believer in spelling it right when we take our vocab quizzes, which will very likely be like word bank. You never know. I don't expect a lot of people to have to write out all the definitions, but they have to match them for sure, like collinear. And if collinear means you're on the same line, then if you have points that are not on the same line, the way we do that in math is we call it like non-collinear with like a hyphen in there. So collinear, on the same line. Non-collinear, like you can see right here if we go back, if I could get back there, like points A, B, and E are non-collinear points. Even though A and B are on the same line, E is not on there, so like they're not. And for those thinking ahead, which I love, right? It's just like if you connect those together, that's not a line because it bends, and we'll learn that that's called an angle, and that's a whole nother day, right? But we're talking about points so far, and we're talking about lines. So we had all those. Now let's get some drawing. So you should have been given a geometer. If you have missed this lesson, you very likely missed the first day, so you'll get your geometer soon. But we'll at least use a straight edge. You can pull out a ruler or like even just like an ID card or something like this. But here it comes. We've got to learn to read this. Again, the symbols can get overwhelming. We're only on the first day in the first 15 minutes here. This right here says draw what now? Draw line XY. So we'll use a straight edge. Everything that we do, if we need to draw it, will be straight. Notice it's got to have the arrows on it also, like going both ways. And then since its name is XY, that means those 2 points are on there. So I will draw 1 point right here. It doesn't matter where it's at, but I got to use a capital letter. It's hard to tell if you make an X capital or lowercase, so we'll just assume that you made it capital, and a capital Y. Yes, you could switch them around. It doesn't really matter exactly where they're at on the line. It's got to be on the line right here. And this is the weird one for people at first, where they're like, draw a C. What does that mean? It's like, so there, I drew a C. That's not what it says, because in math, we've got this fancy symbol that if they use a capital letter, at least in geometry for sure, they want that to be a point C. So we've got to draw this silly little dot right here, which remember, it's supposed to have no size, but since we physically have to draw it, you got to have that. And then this guy right here, draw that. That is a lowercase letter, right? It's italicized, so they want that to be a line. So we'll draw line N in that case. So I'll draw myself a line using a straight edge, no free hands, please. I love those who are artistic, but I like to make things accurate. And we'll put arrowheads on it. And then the N, it doesn't actually go on the line. It goes like right next to one of the arrowheads as like the lowercase cursive letter. So it's not a point. N is not a point. You can tell because it's not a capital letter. And they just put it next to it. It's just a fancy way to name that line right there. So to draw this, a lot of people get overwhelmed with how much stuff they're asking us to do. Welcome to life, brother. But here's what you do. You just do one thing at a time. So we're going to read it first. I'm going to draw line AB, intersecting line CD at point E. Well, the only way to get started with this is to get started. First thing I'll do is draw this. I'll draw line AB. So, bada boom, there's line AB. Any which way, doesn't matter what angle it's going at, horizontal, vertical, oblique, doesn't matter. Just have to draw line AB. What does matter is that, sorry, I hit the wrong button, it needs to intersect line CD. So that means I have to have a whole separate line in this picture, C and D. So I drew myself a line CD, and where they intersect, which we didn't even define that word, but I think you know what it means. It's where they cross each other. Isn't it right there, that orange zone? We'll call that point E. Notice all my letters are capitalized, right, because they're all points. And then our last little guy right here, draw point B, point E, point F, collinear. What's that mean? Collinear? Well, that means they're all on the same line. So I'm just going to do that real quick. I'm going to draw a line, and I'm going to put D, E, and F on there. It doesn't matter which order they go in. I usually just go from left to right, just keeping it simple. They're all collinear. Bada boom. But then you got point G, non-collinear, so we're going to draw point G somewhere not on that line. Usually above it or below it, anything like that. But that's the basics of our vocabulary so far. We have talked about on the same line or not on the same line, and then points and lines so far. Those are the two so far. Those are two of the three undefined terms in geometry. Point has 0 dimensions, and a line has 1 dimension. It's got lengths in this case. So then to get to the third and final of the three, even though there's another word we're going to talk about after that, is plane. Planes happen a lot in the real world that I live in today. Like, you can see the definition, you can write that down. It's a flat, 2-dimensional surface that extends forever and has no thickness. But man, oh man, oh man, if you get into computer graphics or AutoCAD or stuff like this, it's all about selecting planes all over the place. So very, very practical stuff. But we got to understand what a plane is. So it's the hardest thing to see in a geometry class, in my opinion. One of the hardest, because it's like a piece of paper. And sorry for you watching this video that you can't really see what I'm doing, but like a paper definitely has length, and it's got width, and it's true, it does have some thickness, but it's so thin, right? We're just going to pretend that it doesn't have any, so we're going to say that it's got 2 dimensions, right? It's got length, it's got width, but it's got no height. Even back to the game of football that we started with, like you see the word plane in it all the time, that's how you score a touchdown, is the ball must break the plane of the goal line. It's like an invisible shower curtain, is what I always say. Shower curtain's got some length and it's got some height, but it's got no thickness. It's got to have 2 of the 3 dimensions. Or like when the cheerleaders like put out that piece of paper and the football team like runs through it, they're breaking through that one little plane right there. So how do you name a plane? Well, they're even hard to see when they draw them out. You see, it's got some length right here in orange, and it's got some width in pink, but it doesn't have any height. So there's 2 ways to name a plane, and this is how mathematicians, we hate to write, but plane is the bad guy. You got to have the word plane every time. So we got to write the word plane, and then we pick any 3 non-collinear. Look at that. We got a vocab word inside of what we got to do already. Non-collinear means they don't line up in that plane. So here we go. I got to use the word plane. So I'm going to call this guy plane. And then I got to pick 3 points in there, and they can't line up. So boom, boom, boom. For sure, those 3 don't line up. You don't know about like X, Y, and W. It's kind of possible for them to line up, and maybe not, So I'm going to go better safe than sorry and pick 3 points that I know for sure I'd have to definitely bend. So like plane X, Y, Z would be a way. You can see I named it right there. The other way is if they have this weirdo point in the corner. It doesn't matter which one of the 4 corners it has, but it's down here. Notice he doesn't have a dot next to him, right? It's supposed to be this very fancy script that our Microsoft Word doesn't have anymore, so I just use normal like italics. But he's a capital letter, but you can call that plain K if there is like that letter in the corner. Note, you have to use the word plane every time. It doesn't matter if you're using like the long name of him, right, where it's 3 points that are non-collinear, or by his little nickname guy in the corner. You got to use the word plane. So let's do some right here. It says true or false. Use this picture at the right. Plane XYR is a proper name for this guy. So here's what I'm checking. Did they use the word plane to name the plane? Okay, they got that. And then I got to check X, Y, and R. And notice, boom, boom, boom. Uh-oh, those three are all on the same line. And according to the rules here, it has to be non-collinear. So that is false. That's a bad name. You can't call that plane XYR because those 3 points line up. True or false is plane WRX. So they did use the word plane, WRX. Notice those 3 points are in the plane. That's cool, right? And they're not lining up. So yes, we can call that like plane WRX. And then here's the one that could get you, right? You know, it says B is the proper name for this plane. Notice that we got B in the corner right there, but the answer is false because they didn't put the word plane in front of it. If you only have a capital B, that's a point, bro. Name 3 points that are collinear. What does collinear mean? It means they all line up. So any 3 points that all line up, you got a choice of X, Y, R. Notice I made them capital letters and I separated with a comma, right? And that's it. I can't do this like L, R, Z is what a lot of people want to do. L's not a capital letter, right? That's a lowercase cursive letter, and that's another way to name that line right there. So that doesn't work. So this is like the only 3. You can put them in any order you want, but those are the only 3. Next question, at what point, boom, so that's what my answer's got to be, is a point. At what point does line XR, so that's this guy right here, line XR. I'm a big highlighter guy if you like to highlight, see things in colors. And line WY, boom, this pink guy right here, where do they intersect? Well, they cross at point Y, so I will just put the capital Y. Do not put the word point in front of it. I'll actually take off like some points if you do that, because that's not proper. At what point do line M and line L intersect? So I'll go find those guys in my picture here. Line M, see that guy is this dude right here. Line L, we were just talking about a second ago, intersect at point R. And name a point that is not in plane B. Well, that's this guy way out yonder, which is down below the plane. Remember, the plane has no thickness, and this is so hard to see on just like a piece of paper, but like Z is not in the plane right here. When you get back to class in person, I could show you a little bit better. It's like that guy is poking through the plane, and how they indicate that is with this dashed line, like it just shot right through the plane in that case, which, man, planes are challenging. If you find that weird, you are not alone. It is very, very normal to have a tough time seeing stuff with planes, especially on our first day. And then finally, if you have your geometer, we'll use shape number 22. All the shapes are labeled with a number next to them. This is the guy I like to use for the plane right here. So if you just got a straight edge, just try your best to draw something that looks like this. So they say draw plane C. Cool. So that means we're going to put C in the corner. That contains line XR. So line XR is just going to be on the inside of it. And man, we made it this far. We're almost done, but thank you for hanging in there. The last definition of the day is space, right? And space, I'm not talking about like outer space. We're just talking about like space. Space is the set of all points, right? It's got length, it's got width, and it's got height. And I know you might not be in the same room I am in right now, but is there space in your room? Yes, it's got length, width, height. If you go outside of that room, is there more space? Yes. If you go outside of that building, is there more space? And if you get outside of that. So the set of all points where you have infinite length, infinite width, and infinite height kind of stuff is called space. And it's got all 3 dimensions, baby. So there are 3 undefined terms. The point has 0 dimensions. The line has 1. The plane has 2, and then space, he is defined. You know, he's not one of those that we just made up. So it's got 3 dimensions. So we got ourselves a little homework assignment 1-1. Make sure you're using a straight edge to draw stuff, and let us know if you have any questions. Have a good one.